Okay, I want to go ahead and take a look at one of the sections that is a review from chemistry a year ago or 2 years ago, depending upon when you took it. We're on page 46, and we're taking a look at the atom structure. So the key terms on this section would be protons, which we'll talk a lot about, neutrons, a little less, the idea of isotopes and where they fit in, and a little bit about electrons, which really isn't talked about here, but since we're talking about subatomic particles, we're going to talk about them. So this is section 2.5, and so when we start taking a look at it, we're going to give you detail about what's within the atom and its structure. So the two things that we're going to talk about first is what makes up the mass of the atom. So the atom's mass is made up of protons and neutrons. I'm going to go ahead and use the symbol P plus for shorthand, and N with superscript 0, since it has a 0 charge. Later on we'll find that out, and that would be neutrons. Okay, so let's take a look at protons first. So I'm going to look at protons. Protons have a positive charge, and they're found in the nucleus. We know the nucleus is the center. They have a relative charge of a positive 1. What that means, relative charge, is related to the other particles, and what their charges are has a relative charge of a positive 1. Okay? Protons give the atom its physical characteristic. A lot of its physical characteristics. So protons give the atom, or the element, I'll say, many of its physical traits. The atomic number on the periodic table represents the number of protons in an element. Okay, I'll say that again. The atomic number on the periodic table, where you find it, it will indicate the number of protons in an element's atom. Protons are stationary in the nucleus and they don't move. They're not lost or they don't gain protons within an element's atom. So protons are stationary. Okay, so the partner with protons in the nucleus would be neutrons. Give you a little information about neutrons. They are of neutral charge, or 0 charge. they are similar to the mass of a proton. The number of neutrons can vary within an element's atom. So this is where we get this term isotope. So an isotope has a different number of neutrons within a particular element's atoms. So we can have different number of neutrons in atoms of the same element. So I'm going to give you the definition that I feel is good, which would be atoms of the same element with a different number of neutrons. So this is just a lot of information that I think is detailed and that I would like you to know about the structure of an atom. All right, let me give you an example of a couple isotopes. So we can have isotopes written in several different ways. The way we're going to use it is going to be the symbol. We're going to use magnesium. The top number, which would be the largest number, superscript, for magnesium, we're going to go ahead and give you two different numbers. One's going to be 24 over 12. And then we're going to have another symbol for magnesium. It's going to be 25 over 12. Okay, so the 12 indicates the number of protons. If you notice, these two have the same number of protons. The 24 represents the mass number. So remember, we just talked about neutrons and protons, and they make up the mass of a particular atom. So the mass number is made up of protons and neutrons. So if we take, for example, the first one, we take 24, which is protons and neutrons, minus 12, which is the protons, we're going to get the neutron number, which is 12 neutrons. And then for the second one, same thing. We're going to take 25 minus 12 neutrons, or minus 12, and then that's going to give us 13 neutrons. See, so we can have two atoms of the same element, but with a different number of neutrons, which gives it a different mass number as well. So in the future, you'll have to work with that a little bit. That's just review. And then the last thing that finishes things up, we're almost done, is dealing with electrons. Electrons, we're going to go with an E minus for shorthand. They are located outside the nucleus. They have a relative charge of a -1 opposite of protons. So they'll cancel each other out if we have equal numbers of them. Electrons give the atoms most of its chemical properties. Electrons can be gained and lost by the atom. Okay, so scenarios. When electrons are lost, the charge is positive. When electrons are gained, the atom's charge is negative. And then when they're equal, well, that's going to be neutral. So just a review, we talked about protons, neutrons, and electrons, and the characteristics of those individual particles within the atom. And we talked a little bit about isotopes and what isotopes are. They are atoms of the same element with a different number of neutrons, which gives it a different mass as well.